Hey everybody. So good morning. Hope you had a nice weekend. Today what we are going to do is we are going to do our final investigation for the year. So I mentioned earlier last week that our last investigation is going to be a little bit different in format. It's pretty quick and there's really not a lot of new information to learn. It's more about reinforcing some of the things that we've already learned. So I'm going to just simulate it for you. You'll watch this video, answer some questions, take some notes, and then we will be done with our final investigation. All right, so this investigation is called For the Birds, Designing Solutions, and it tests, as we see here, independent and interdependent relationships in ecosystems. So at the end of our last unit, if you guys remember, we spoke about how it's super important that organisms are able to interact with one another, but also important that they interact with what's going on in their ecosystems and their environments, right? Because we mentioned that when you change something, when humans remove organisms, or when they change up the habitat, or they tear down trees, or they do anything to disrupt the dependency that these organisms have, it results in issues. It results in the death of organisms. It results in disruptions. So this investigation is a way for us to sort of visualize that in a really easy and simplistic way. And it involves something that happens very, very frequently in the United States. So we're going to get into that in a few seconds. To let you know, this video is going to pause and stop and start a couple of times. I'm going to try and make it as seamless as possible when I format the video. Reason is because there are parts of this that I'm going to have to record because I am going to be doing the simulation and I'm going to show you that. So I'll try and make it as seamless as I can, but do realize that there's going to be changes pretty abruptly, okay? All right, so before we get into the actual simulation, just a couple of vocab words that are important, not just for the simulation, but in general for this unit and for this class. Some of them you probably already know. I'm just gonna read through them here. Do make sure that you are taking notes on these things. So first and foremost, habitat, which is the specific physical environment where a particular organism lives and where they obtain their resources to survive, grow, and reproduce. So we've been discussing that all unit. That should not be new info to you, but it is an important piece of information to remember. Reliability. So in bio, the reliability is the degree to which a biological measurement or experiment yields consistent, repeatable results under the same conditions. And so having an experiment that is reliable is important because it makes your data valid, right? You want validity. You want your experiment to be valid, and so you have to have reliable data, reliable measurements. Force. Force is a push or a pull, right? So something like a muscle contraction or fluid pressure that changes the motion or shape of a biological structure. And force is important in this investigation because we are going to be using force and we are going to be taking note of a physical change, right? So we're going to get to that in just a few minutes. Mass, the quantity of matter in a biological object or organism, right? Typically, we're going to label this as body weight or biomass. It's how much of something there is of a particular organism, which is also important in this experiment because we are weighing things and using very specific numbers. We'll get to that in a few minutes. Diameter, right? Diameter is the straight line distance passing through the center of a circular structure, right? In our case, it's going to be, a simulation of a bird, right? And we're going to use a circular something for that. We'll get to that in a little bit as well. And we're going to have to measure the diameter of something. So you will see that pretty soon. Mortality. So mortality is the incidence of death within a population, usually expressed as a rate over a defined period of time. So the mortality rate of humans, the mortality rate of birds, the mortality rate of any organism, right? It's just saying how much of that particular organism is dying in any given time frame, All right, then we have independent and dependent variables. As we have been discussing independent and dependent since literally the beginning of the year. It was on your final. You do absolutely need to know what these two are. If you still do not, please review your notes and do some studying on that. So remember, independent is going to be the factor that the investigator deliberately changes in an experiment. So it's the changing variable. It's something that you are able to change yourself. And the dependent variable, as the name suggests, is something that depends on it, right? So the response, it's the outcome, right? So, you are checking to see, how temperature affects the growth of a plant, right? You want to know how temperature affects the growth of a plant. Temperature is your independent variable. You can change that and you control that. You could make the temperature in the room 30 degrees, 50 degrees, 80 degrees. The plant growth depends on the temperature, so that is going to be the response, the outcome, the thing that you're measuring. All right, please make sure you know the difference between those. You then have constants and constraints. So a constant also, we learned this back when we did scientific method, something that remains unchanged during your experimental design, right? You don't want to change that because you don't want to alter your results. And a constraint is a limitation. So when there is a constraint, something is limiting the ability for you to do this experiment. It could be anything: time, resources, ethics, money, space, right? Participant availability, right? Any of it is a constraint. So it's just something that is going to happen. There is no perfect world. There's no perfect scenario for experiments. So there's always going to be something that is a constraint. Okay, so please make sure everyone, you know these words. They are important. Okay. All right, so let's start the investigation. So session 1, part 1, chickadee. So chickadees, everybody, are birds, real birds. And we are going to design, evaluate, and revise a solution for reducing the impact of a collision between a bird and a window, right? We want to reduce the impact of collision. And when doing that, the goal is to minimize the chance of bird mortality, right? We don't want that bird to die, and so we're going to try and design something where we lessen the mortality rate of this bird. Okay? Bird strikes. So guys, this video is not loading for me right now. If you want, you can Google it, you could YouTube it. Literally just YouTube what you see here: why birds hit windows and how to stop it. I believe it's the very first video. I think the account name is Bird Nerd. So if you want to watch it, you can go ahead, but I'll just quickly explain what you would see in the minute and 15 seconds that we would have watched. Essentially what it's saying is that birds, nearly 1 billion, that's 1 billion birds every single year in the United States are killed because they fly into windows. And that's just a fact, right? It's a little under 1 billion. It's like 980 million, something like that. But it's close to 1 billion a year die just because of the impact of flying into a window. And so the video goes into some information about why that happens and why we could stop it, but really all we're focused on right now is why it's happening. And the main idea is that the birds can't see that it's a window. It's clear, right? They are flying along and it looks like, it doesn't look like anything to them. It looks like sky. And so they continue to fly and it ends up being glass and they hit it and die. And so it's really significant because 1 billion birds a year, right? That is a significant amount of birds, right? And that is impacting their species, but it's also impacting the ecosystem and other species. So how could we fix that? Right, and the video goes into depth a little bit of how we could do that. I don't want you to watch any more of the video because that's kind of the point of this investigation, is to design something that could stop bird deaths. And that's kind of what we're going to do right now. So just as an intro, I'm going to leave this up here for you, and you could pause this and read this. But in short, it's saying again that almost 1 billion birds die each year. They perceive their reflection in the window as habitats. They are attracted to plants that they might see indoors. They mistake windows as open spaces that they could fly through. The idea is that the window is confusing to the bird, and it is, it's not clear to the bird that this isn't something that it can't fly through, right? It's confusing it. So there are, efforts in the US and Canada to reduce these collisions, make buildings more bird friendly. Remember that when we're designing our experiment, and we're kind of going to just, we're going to move through this a little more quickly than we would have if we were doing it in person. But remember, there are constraints with any plan. I mean, think about, building new buildings to help birds. I mean, you have things like cost, aesthetics, safety, reliability. You have to recognize that there's always going to be something that is going to not, allow you to do this in the way that you might want to, right? There's something that might be a constraint. It just is reality. So let's figure it out, right? We've identified the problem. Birds are striking windows and dying. Possible solutions, and then what we're going to do to investigate it. So I urge you to pause the video now, and maybe in your notes, take note of a couple of different possible solutions that you think might be able to lessen the number of bird strikes in windows. All right, and so again, pause the video and put that in your notes, okay? All right, so here's our first simulation, all right? And I'm going to explain what we're doing, and then I'm going to stop the video for the first time because I got to set it up, and then we'll come back after I record the video. All right, so the first bird we're dealing with is a chickadee, all right? There's an image of it, obviously not to scale, but that's what it looks like. The average adult mass of a chickadee is only 12 grams, right? And so I really need you to recognize that that is a crazy small number, right? Birds are extremely, extremely lightweight. Their bones are hollow, and they don't have a lot of muscle. Their skeletons are very, very small. So they are really, really light birds. The average chickadee is about 19.3 kilometers per hour. And so when you are converting that to miles per hour, right, they're able to fly about a little under 12 miles an hour, right, 11.9. No, that's not right. Sorry, guys. That was me converting kilometers to miles, like actual length. Let me Google kilometers per hour to miles per hour, because I don't know that off the top of my head. So that would be crazy, right? If the bird flew 12 miles an hour. It is... Oh, yeah, no, it is. It's the same thing. Okay, so it is just under 12 miles an hour. It's a very fast bird. I thought that was wrong, but it's not. So just under 12 miles an hour. And again, if we are trying to convert grams to pounds, something that you may be more familiar with, or grams to ounces rather, that's probably a little bit more accurate. It's like half of an ounce, right? So this bird doesn't even weigh 1 full ounce. And use that as a comparison to things that you know in your daily life, right? Like there are 16 ounces in 1 pound. If you're drinking a bottle of water right now, maybe the bottle of water is 8 ounces, right? And so this bird is less than 1 ounce. It is a very light organism. And we're going to simulate the drop height at about 1.5 meters. So meters to feet, right? For every 1 meter is about 3 feet, give or take. So 1.5 meters is going to be about 5 feet high. So when we simulate this bird hitting a window, right? Because I, of course, cannot have an actual bird hit a window. We're going to simulate this a different way. I'm going to drop the bird from about 5 feet high, okay? And so this is kind of the collision and the simulation we're going to do. And again, I'm going to actually do this, and you're going to see it in just a minute or two. So What we're using for the model of a bird, everyone, is modeling clay, right? Clay that you use to like shape and make different objects and stuff. It's malleable, right? It is able to be shaped into different things, and it is not so solid that you can't indent it, right? And so you'll see here the deformation, right, after you drop it. Instead of it being a round ball like it is before the drop, you'll see that the bottom is flat, right? And that is an indentation which will represent a bird hitting a window. And just so you know, everyone, for this experiment, anytime there is an indentation in the clay, that indicates bird mortality, right? If the clay is indented, that means that the bird would be indented, right? The skull of the bird would have been indented and it would have killed the bird. And so what we're going to do is we're going to drop clay balls, right? Different weights, different sizes to represent different birds. And we're going to measure the indentations. And we're going to then devise a plan to create something that may lessen the indentation, meaning that we're going to, help the birds survive. And so we're going to do that. So I'm going to pause the video here because I'm going to set up our first simulation, and I'll get back in a second. All right, everybody. So I am going to do our first simulation. So what we have here is a clay ball, right? So we have to simulate a bird somehow because we, of course, cannot use a real bird in this investigation. And so what we're using instead is a ball of clay. The clay is round, right? I'm going to move it around. There are no indents. It is as perfect of a sphere as I can get. And so that is showing a bird that has not yet hit anything, that has not yet been damaged. And so to investigate the impact of a bird hitting a window, we're going to take this clay ball and I'm going to drop it from a distance of about 5 feet. Right, that's where that yellow mark is. It's about 5 feet from the ground. And the reason that I'm using 5 feet is because the time it takes, the velocity for this ball to reach the ground is about the speed of the chickadee at its maximum speed, impact of hitting a window. So when we drop this ball, what we're expecting to see is one part of this ball, wherever it drops, is going to have an indent, and that is going to be the impact of the bird hitting the window. So I'm going to drop it at about 5 feet. And then when we look at it, we're able to see that it's flat, right? Do we see that flat bottom, right? The impact of this bird hitting the window has now caused an indentation. And I'm going to pause for a second. All right, guys, I am back. So there's the indentation. What we're going to have to see now is, I'm going to put the camera down for 1 second. We have to measure what that indentation size is, and then just take note of it, right? So it's going to be a little bit tough because I don't want it to roll. Okay, so if we take a ruler and we use centimeters, right, we're going to be able to see that the indentation is approximately 1.5 centimeters, give or take, right? I can't be super specific here, but 1.5 is pretty good. So 1.5 centimeters is going to be just how big of an impact is caused, how big of an indent, rather, is caused when the chickadee hits a window going at its maximum speed, okay? And so now that we have our baseline, our control group, we're gonna have to figure out a way to develop some system that is going to hopefully reduce the impact of this bird when it hits a window, right? And the goal is to create something where it doesn't die, which means that there can't be any indent on the bird, okay? All right, guys, so let's take a look at our proposed change to hopefully lessen the impact of this bird hitting a window and hopefully preventing its death. So what we have down here is a mesh screen, right? So this is a ring with a mesh on it. And so the idea that we're proposing is if we put mesh across windows, is it going to lessen the impact by lessening the force that the bird hits the window and therefore preventing it from dying. And so we're going to drop the bird from the same height, and it's going to land on this mesh, and we're going to see if there is any impact or any deformity that has occurred. All right? Let's take a look. All right, so if we take a look, we're going to see that there is certainly a deformity, right? It has now indented the mesh. The mesh has rather indented the clay, meaning the bird is now going to have indents on it, but it also caused a deformity because we'll see that this is flat, right? If we look at it from here, it is a flat top. So let's see though, at the very least, did it lessen the size of the deformity? And it did. It's now a centimeter. So it lessened it by 1/2 centimeter, which seems insignificant, but probably isn't for an actual living organism. So we did see some improvement here, but remember what we said at the beginning. If there's any indent, the bird is dead. So we have to see if we can figure out how we are going to prevent any sort of deformity from happening. So let's see what we could do to improve that. All right, guys, so for our modified experiment, what I've done is I've taken a couple of Jenga blocks and I placed the Jenga blocks underneath the mesh window. And so what I'm thinking here, right, this is my experiment, is maybe the reason why there's still impact and there's still deformities on our bird is because the window is a flat surface, right? There's no space between where the bird hits the window and where the window actually is. And so maybe if we raise the window a little bit so that it's not directly flush to the building, right? There's a little bit of space now between them, that it's going to provide less force, and therefore there's going to be less indentation, less deformity, and less death of this bird. All right, so let's see if that is accurate. So we have our bird again, it's all good. We're going to drop it from the same height, and we're going to see if there's a deformity, right? Well, let's let it, so take a look at this. There is, but clearly less than before. I mean, it's definitely not as flat, guys, right? We're able to see that deformity present, but it is definitely still rounded a little bit. So this bird is still dead, yeah? But it is certainly going to be not as dead. So take a look. It's now under, oh, that's inch. It's now just under a centimeter of where the deformity is. So raising the height of the window, right, by pulling it away from the building is going to lessen the impact. So perhaps one thing that people could do when they're designing windows and buildings is not keep the window super flush up against the concrete or the metal or whatever siding the building has. Have a little bit of a raise, because it clearly is going to, as we see here, lessen the deformity and therefore reduce the mortality rate. All right, guys, so we now have information about our chickadee, right? When we increase the height of the window, and when I say height, it's because we're talking about a floor, but really think about pushing the window away a little bit from the siding of the building. And when we add something to the window, like a mesh, you're going to reduce the force of impact and therefore reduce the deformity and therefore reduce the chance of mortality. Now, what we're going to do is we're going to just try this one more time with a different bird to see if the experimental results we just got hold up, right? Because we want to make sure that when we do an experiment like we've learned, you want to have multiple trials and you want to have different organisms participating so that we could see if this is a real a real result that we're getting. So the next bird that we're going to try is the gray catbird, right underneath the chickadee. And right off the bat, you're able to see that the gray catbird is a bigger bird by a significant margin. It's almost 3 times as heavy as the chickadee. It is a big bird, but what we'll notice is that its flight speed is the same as the chickadee. So it's a heavier bird, but it flies just as fast. And so you should already start thinking to yourself, what is that going to mean for impact, right? What does that mean for force? What does that mean for deformities when a heavier bird is traveling at the same speed as a lighter bird? Is it going to be worse, or is it going to be not so bad? And the height is going to be the same as well, 1.5 meters. So we're going to test out this theory, and we're going to see exactly what happens. Okay, so I'm going to pause the video again and get set up. All right, guys, so here's our gray catbird. We have a different color, it's a different bird, and it is a much bigger ball of clay than before. And just for reference, that is our chickadee. So it is significantly larger, and we're going to do the same exact experiment. Instead of pausing the video, I'm going to just place the phone down while I am setting up the other stuff, just for the purpose of time here. All right, so we have our gray catbird. Is that what it's called? Yes, gray catbird. And we are dropping that guy from the same distance, 5 meters, 5 feet rather, 1.5 meters, and we're going to see what the impact is. Remember, when we did this the first time with nothing on the ground, right? So this is just our base. Our chickadee had a deformity of 1.5 centimeters. All right, so let's drop him. And that was a much heavier impact that I'm sure you heard. Let's take a look. Okay. So there is our deformity, right? This guy does not want to stay still. I guess he's dead, so that makes sense. There is the deformity, right? Very, very big deformity. So if we were to measure, we're going to see that this deformity is just about 2 centimeters, right? So it is bigger than the chickadee, and that makes sense, guys. It is a heavier bird, right? It's a bigger bird, and therefore it's able to make a impact that is more significant, right? It is going to cause a more significant deformity. And so let's test our theory and see if there's going to be a change. So I'm just setting up the screen, all right? And what we see, well, I gotta roll this bird back out so that there's no deformity. So bear with me for just a second. Okay. So there's our screen, there's our height, there's our catbird, and there it is falling. All right, and so when we take that guy, we're going to again see a significant deformity, right? Really significant. And so when we measure that, we are still, guys, at 2 centimeters. So the first difference that we're seeing here is that just adding a mesh did not lessen the deformity radius, right? The impact was the same. And that is different because when we added the mesh for the chickadee, just the mesh dropped the deformity radius a little bit. But we're not seeing that here. And so now let's try our final attempt raising the mesh off the ground and seeing if that is going to change the radius of deformity, therefore lessening the impact and lessening the death of the bird. All right, so I'm just getting the Jenga set up. Give me a second. All right, so here's our bird. All right, let's drop it and see what happens. Well, first of all, it fell, right? But the bird did hit the mesh. So let's see what happens and then talk about what it breaking means. So right off the bat, everybody, that is a much less significant impact. And it's also round, right? I don't really see much of a flat area here, which indicates to me, I would say that this bird is still alive, actually. So that was a very successful experiment. But what does that mean, right? Anyone want to think about it? I know I'm not there with you. You can't answer me where I'll hear you, but think about what this is. We learned about a word at the beginning of this lesson. And hopefully you're thinking a constraint. A constraint for this particular bird is that the experiment that we created is not strong enough to withstand the impact for this bird. So building the same exact thing for the chickadee is not going to work for this guy. That's a constraint. It's also something that you need to take into account when you're doing any experiment, that when you have different populations, when you have different organisms that you're dealing with, one result that might work for one person is not going to work for all of them. And so that is a significant constraint. It did prevent this bird from dying, but we would have to figure out a way to build this where it's not going to break and collapse every time a bird hits it, right? Because like we said, almost 1 billion birds do this every single year. So you're going to go ahead and fix your window 1 billion times a year? Not possible. So we have to figure out how we are going to do that. All right. So that was the investigation, everybody. There is still going to be a couple of things that I want to tell you, that I will tell you following this next pause. So yeah, let's get to that. Okay, guys, so again, that is the end of our investigation. I'm just talking to you from this homepage here, just to give you a heads up on what you have to do for this investigation. So we're going to have 2 things that you have to submit for this investigation. They are on the assignment that was posted on Google Classroom for this video for today, and then tomorrow you're going to, of course, get another one. Today's assignment is simple. You are going to submit the notes that you took of this video, right? So as you were watching this video, as you were watching the investigation, you should have been taking notes. You should have taken notes on the vocab words that we went through. You should have taken notes on the video clip that we didn't watch, but I explained. You should have taken notes on the materials that we're using for our bird simulation, what the materials we used were, why did we use those materials, how did we set up everything. So essentially, you are giving us a submission of your notes that shows us that you watched this video, you listened to what we did, and you have an understanding of the investigation. That is today's assignment, all right? Tomorrow's assignment will be answering some questions, and when we give that to you tomorrow, we will go over it at that point. All right, guys? Have a great rest of your day, and we will talk tomorrow.